Hello, everybody. It's Mrs. Pound, and I'm back with more from Chapter 4.1 about water. Today, our topic is going to be the water cycle from Section 412. So, our objectives today are going to be to explain the major components of the water cycle and to determine the factors that affect a region's water budget. So here is a diagram of the water cycle, and there is a lot going on here, and we're going to take a look at some of the different parts of this. But an important thing to know is what runs the water cycle is the sun, okay? And it is a cycle. So it has no beginning or end. There's not one spot where you can say it begins or where it ends because it's all just happening continuously together. One process that can occur in the water cycle is evaporation. This is the change of a substance from a liquid to a gas. And here in the picture in the background, you can see it looks like maybe a pond, and it looks like some evaporation has taken place. The sun provides energy to the water, and that energy allows the water to change from a liquid to a gas and go into the atmosphere. Now, most of the water in the atmosphere that evaporates is from the oceans, okay? And it evaporates from any water source, but most of it's from the oceans because most of our planet is ocean. However, very little actually falls on land as precipitation. Most of it does, in fact, fall back into the ocean, but winds will blow some of it across the continents as precipitation. There's also transpiration. This is the loss of water by plants. And so you can see here is some fog that looks like it's coming up from the trees to give you that idea. Plant transpirations are affected by three things. The first thing is wind. Okay. On very windy days, that can increase plant transpiration, the amount of water that they give off. Temperature also. Uh, Transpiration increases when it's warmer and decreases when it's colder because photosynthesis will increase with temperature. Also, precipitation. If there's not much precipitation, it's dry out. The plants have structures called stoma that close and to preserve the water if there is, say, a drought. And then if there's plenty of water, they will open those up to let more water out through transpiration. There's also condensation. This is the change of a substance from a gas to a liquid. So in the water cycle, you'll see this is dew. This is what forms the clouds. This is actually what forms fog, even though I showed fog as the evaporation, because we actually cannot see water vapor. We don't know that it exists until it starts to condense. And so that's why I showed it in that form in the picture. So the for condensation to occur, there has to be a loss of energy. So, usually, where you have cool surface, high altitude, you're going to have condensation. Then there is sublimation. This is the change of a substance from a solid to a gas without passing through the liquid state. This is going to happen where you have snow, especially at high altitudes where there's lower pressure, lower humidity, maybe very dry winds. You're going to have some sublimation taking place. You also notice sublimation in your freezer when ice cubes shrink. That's because they are sublimating, and then they deposit themselves elsewhere in your freezer as frost. And so that's actually where frost comes from as well. It's sublimation of, say, snow and then deposition back onto a cooler surface. Now let's take a look at the water cycle with groundwater. So water is propelled through the water cycle as it travels in the form of groundwater. So we're going to look at just one portion of the water cycle. So here's our water cycle. We're talking about groundwater here. So let's first talk about How does it get there? How does it get underground? We're going to talk about water more. It's basically uh, water that's underground, and it's a lot like underground rivers and lakes and everything. So, water from precipitation or condensation seeps down into soil and rock crevices to be stored underground in the form of groundwater. So, it falls on the land, it goes through the ground, which is a good thing. It filters out a lot of impurities and toxins and different things. Next, the water travels through aquifers. These are like big underground lakes and things, and eventually reaches land where the water table cuts across Earth's surface. So the groundwater goes under here, and see, it's the water table is the level of the water. Here, the water table is at the top of this lake. Here, the water table is at the top of the ocean. The water table is the level. Okay, and here are this looks like an aquifer storing some groundwater down here. When groundwater reaches land, it has the opportunity to evaporate or flow as runoff into the ocean and to continue in the water cycle. So it may take it longer to travel underground and things, and it might be trapped down there for longer, but it eventually will come to the surface and say the oceans or in lakes and things. It will evaporate or and precipitate and run off and all of those things to join the rest of the water cycle. So there's your water cycle again. We've talked about evaporation, precipitation. We did not talk about runoff, but that's an important part of it. We have seepage up to the surface, um, fog drip, dew, evapotranspiration. So that's that transpiration from the plants. All of those aspects of the water cycle. And like I said, you cannot pick a spot for it to begin or end. It's just one big cycle that is happening continuously. Now, water budget is the relationship between the input and the output of all the water on Earth. So, just like a budget, there are expenditures and there is income. So, income would be water going into the system, which would be things like precipitation, runoff, those types of things. Output would be evaporation, transpiration, where you're losing water from an ecosystem, from an area of the earth. And one thing we need to know is that the global water budget is balanced. The local water budgets are usually not balanced. There's only so much water on Earth, and it's constantly in the cycle. So wherever there's input, there's output somewhere else. Okay, throughout the earth. But that input and output may not be in the same place. That's why local water budgets are usually not balanced. Locally, you might have drought, which means you're spending more water than you have. Or you might have a flood, which means you have too much water. You have an influx, you have an income of too much water. So that's what I mean by local water budgets are not balanced. But globally, if water's going in, water's coming out somewhere else. So our objectives were to explain the major components of the water cycle, to determine the factors that affect a region's water budget. So 5 questions, and I will be back with more about water.